So what this is an online practice test. Yeah, it's a little hard to read because it's small. I know that. So what you can do is I rewrote the problem right here. So you can use this. So we're trying to reduce that thing and figure out which answer we're going with. All right, guys, so let me show you a really good hack for this one. So obviously, all right, so Haley's going to go with B. Okay. So obviously, this thing must divide into this, right? Because we only have a single term. So the hack for this one is look at the numbers. We've got -6 divided by 2. -6 divided by 2 is -3. Well, the only answer that has -3 is B, right? The other part of it you could look at is if you take 2x squared and divide it by x, you'll get 2x. So again, use the fact that you know this thing is going to divide by it. So if there'd have been two of them with -3, then we'd have done this part over here and came up with the 2x. But that's our guy. All right, so we're going to go with 2x minus 3. Move on. All right, so they want this guy factored. So again, I'll rewrite this for you. So let's get a new screen going. All right. So then this guy is going to be 12 x to the 4th minus 27 x to the 3rd, and then plus 6 x squared. Okay, so if you look at your answers, obviously we can factor out a 3x squared. So let's go ahead and do that, because all the answers start with 3x squared. So if we do that, then the first guy here, we got 12 divided by 3, that's going to be 4. X to the 4th divided by x squared is going to be x squared. And we have minus 27 divided by 3, that's minus 9. X to the 3rd divided by x to the 2nd is just x. And the last one, we've got 6 divided by 3, that's 2. And the x squareds cancel out. So there's our guy. So that's really what you need to factor is this part right here. So factor that into two pieces, and that'll give us our answer. So notice that our number is plus 2, right? Well, let's look at our answers. A would give you plus 2 because you got the two minuses, right? B has -1 plus 2. That'd be -2. So B doesn't work. C could work, but then look at D. You got 1 times -2. That's -2 as well. So just by using that 2 there, we are able to figure out that B and D do not work. So we get it down to A or C. So I'll let you guys work on it and figure it out from there. Again, if you don't want to factor, you can just multiply the two back together and see which one gives you a middle term of -9. You're freaking out? Why? It's not that big a deal. Everybody just needs to relax. All right, so let's check out our possibilities. So A, we figure it's got to be A or C, right? So A, we've got 4x minus 1, and then times x minus 2. So Haley, you're thinking it is A? Okay. So again, all you have to do is look at the inside outsides, right? So if we do that, we've got -1 times x, so that's minus x or minus 1x. Then we've got 4 times the -2, that's minus 8x. So minus 8x and minus 1 more is minus 9x. So again, if you get these guys to match up, we're good to go. So yeah, we're going to go with A on that one. Cool. Moving on. All right, so then we'll know the distance between these 2 points. All right, let's bring up another slide. All right, so this one, our 2 points are -3, 4, and 1, 6. Okay, then our possible answers, since they're kind of hard to read, it's going to be 3 square root of 2, 2 square root of 3, and then 2 square root of 5, and finally 2 square root of 2. So that's our answers. So again, this is something we can do on our calculator as well. All right, so mess with that for a little bit, and then we'll talk. All right, so the distance formula is really the Pythagorean theorem in disguise. And you know the Pythagorean theorem shows up all the freaking time, right? So here's what we do. Let me change colors here. All right, so here's what we do. If you go from -3 up to 1, how many spaces have we gone up? So from -3 up to 4, how many spaces is that? No. Think of it this way. If you're at 3rd Street South, you want to go to 1st Street North, how many blocks do you go? Yeah, 4, right? Okay, so that's 4. Then if we go from 4th Street to 6th Street, how many blocks do we go? You go from 4 to 6. Yeah. So I said it's Pythagorean theorem, right? So that means we're going to square this guy, and add them together. So 4 times 4 is 16, and 2 times 2 is 4. 16 and 4 is 20. And then we have to square root that guy. So the answer is the square root of 20. So you notice we don't have the square root of 20 as any of our answers, right? So how do we figure out to go from here to here? All right, so I'll show you the official way, but I'll show you the calculator way too, okay? So the official way is we look at this and we say, okay, well, what is a perfect square that we can divide into 20? Our first perfect square is 2 times 2, that's 4. Can we divide 20 by 4? Okay, so it's 4 times 5, right? So it means we could rewrite this as the square root of 4 times the square root of 5, because 4 times 5 is 20, right? The reason we do that is we know that the 4 is a perfect square, so the square root of 4 is just 2 times the square root of 5. So this is our guy. Now, if you didn't want to go through all that, what you could do is you say, all right, let me get my calculator out. Let's move into the scene here. All right, so I get my calculator out, and I say, okay, I do 20, and I take the square root. So 4.47. And we look at our answers and we say, okay, which one's going to give us that? So you could just start at the top. So we say we go 2 square rooted times 3. So that's only 4.24. We need 4.47. So that's not our guy. So next one we do 3 square rooted times 2. That's 3.46. That's no good either. So we go to the next one, we say 5 square rooted, and then times 2. So you just plug this stuff in your calculator. 4.47, that's our boy. So that's another way to figure that out if you don't remember how to convert. Okay. So let's say 2 square root of 5, and move on. All right, so let's bring our scratch pad back into play here. See, the interesting thing is I have 3 screens, but I can only write on one. But what I do here with this PowerPoint that's like shaped like a regular piece of paper, you're looking at the slide portion of it, but I've got the actual thing on my screen I can write on. So this one is going to be 3x to the minus 2, and then raised to the 3rd power. Okay? And our possibilities are 27x to the minus 4, 9x to the minus 6, 9x to the positive 6, and finally 27x to the minus 6. All right. So first things first, we look at it and we say, okay, we have to raise both these guys to the third power, right? So we're going to raise him to the third power and him to the third power, okay? So what is 3 to the third power? What does that equal? What is 3 to the third power? $27. Good. Because it's 3 times 3, which is 9, times 3 again, which is 27. So immediately, we can get rid of 2 answers, right? So we'll go ahead and do that. So these guys are wrong, okay? Now, when you have something that has an exponent and then you raise it to a power, what do we do with the exponents? Add, subtract, multiply, divide, what do we do? So I've got negative 2 power, and then I'm raising that to the third power. What do I do with those guys? So what do we do with the exponents? We're going to add them, subtract them, multiply them, divide them. What's happening? When you have something that has an exponent and then you raise that to a power, what happens? Yeah, we do multiply. Good. Well, even if adding was correct, which it isn't, but even if it was, you add those together, minus 3, or I mean, excuse me, 3 and minus 2 would be x to the first. We don't have an x to the first. So that would probably indicate that we need to multiply, right? So negative 2 times 3, that's minus 6, right? This says minus 4. So that's our guy. Make sense? All right, so we'll go and do that one. All right, so it says we have 2 lines, 2x plus y equals 0 and y equals 3, plotted on a typical coordinate grid. At what point will they intersect? Okay, so let's write this stuff down. Here. All right, so we've got 2 lines. We've got 2x plus y equals 0, and the other one we just have y equals 3. Okay. So what we have here, we have a line, and then we have a horizontal line at y equals 3. So here's our answers. So we've got minus 1.5 and 3. We've got 4 and 1. We've got 1.5 and 3. And then finally we've got minus 1.5 and 0. Okay, so here's the thing. The one says y equals 3. So So y is some constant number, and that constant number happens to be, you guessed it, 3. So y is always the second in our ordered pairs, right? So which answers are automatically wrong? Because it's literally telling us that y equals 3. So which answers are wrong right out of the gate? B and D, perfect. Because their last digit is not 3. So these guys, gone. All right, so how do we figure this out? Well, it says y equals 3, and then it's 2x plus y equals 0. So this is the same y. So yeah, we're kind of feeling A, right? Because what you do is you'd say, okay, I'm going to do 2x plus 3 equals 0, right? We move to the other side, you get 2x, subtract 3 off of both sides equals negative 3. And then we divide by 2. So x equals minus 3 halves, which is the same as saying minus 1.5. So that's our boy. Does that make sense? All right, so let's go and select A. Check out another one. Wow. This is written really bad, so we're definitely going to have to rewrite this. Give me a second. All right, so let's bring up a new guy here. All right, so this guy, what this should say is it should say 3. Then here we're going to have 6x minus 3 over 3. And then minus 3 times 9x plus 9. Okay, so that's what's going on there. All right, so if we are trying to simplify this thing, what's the first thing we can do? We have a couple different moves we can do, but what's your first move? Distribute, we can definitely do that. So we'll go ahead and do that here. So we're going to get minus 27x and then minus 27. Good. Now what can we do to the first guy here? What can we do to this guy? Well, what can we do with those 3's? Yeah, the 3's cancel. That's a beautiful thing. Get rid of those guys. So now I've got 6x minus 3 minus 27x and then minus 27. Okay. So what can we do here? So we can put these guys together, right? So I've got 6x minus 27x, that's going to be minus 21x. And then I've got minus 3 minus 27 more, that's going to be minus 30. Okay. So that's a perfectly good answer, but I don't see that answer. Do I see anything that's close? Our answer is correct. And there is another answer on there that is the same thing. And that's what we need to figure out. So which one of the answers do you think it could be? You're going with D? I think that's a good idea. Because if you notice, we've got 21, we've got 30. We can divide both by 3. And they usually bring the negative out front. So if they bring the negative out front, right, then we've got minus 21 divided by minus 3, that's positive 7. Bring the x along for the ride. And then we've got minus 30 minus 3. So 30 divided by 3 is 10. The negative signs cancel out and become positive. So yeah, that's our guy. Good. All right, let's see what the next one is here. Okay, so this one's not too bad. We'll finish up on this one. All right. So last one today. So we've got x minus 2y, and then that whole thing is squared, and they're telling us that x equals 3 and y equals 2. So we're just plugging in, right? So go ahead and take a couple minutes and plug in, and we'll see what we come up with. Okay, so Haley is thinking A. All right, so I started the process for you here. I went ahead and plugged in the 3 for x, the 2 for y, and it came up with this. All right, so we multiply first. We're going to do the 2 times 2. So this will be 3 minus 4 squared, right? 3 minus 4 is negative 1 squared, which is really negative 1 times negative 1. The negatives will cancel out. Plus, anytime you square something, you get a positive number. So we get plus 1. So yeah, it is A. Good. All right. Now, on that happy note, I think that's a good place to stop. So I've already got attendance for you guys. So I'll just shut down the recording and see you all next time.